All right, so what you guys do have to be aware of with this, with trig inverses, when we take derivatives and integrals, you do want to know their domain and their range. Okay, so normally for a sine function, so if I just wrote sine of x, if I asked you what is the domain of sine of x and what is the range of sine of x, its domain, you would tell me it's negative infinity to positive infinity. Okay, and the range would be from -1, actually this is inclusive, -1 to 1. Okay, so that's what you would tell me the values would be for this. Okay, if I asked you to give me the same information for cosine of x, your domain would be negative infinity to positive infinity, and your range would be from -1 to 1. Okay, and we're just going to mention one more here. Tangent of x, your domain is, it's everything, kind of, okay? It's all real numbers, but it doesn't exist at 90-degree values. Remember, because tangent of 90 is undefined? So you really can't graph anything at 90 degrees, at 180 degrees, at 270, at 360, etc., and in the backwards direction. Other than that, every other number should work, but its range, for us, it's negative pi over 2 to pi over 2. Like, that's where it exists for us, okay? Actually, wait a minute. I just crossed these up. I'm sorry. I wrote these backwards. My domain is negative pi over 2 to pi over 2 because that's where it exists. And the range, remember the graphs for tangents go like this, right? So they go down forever, up forever. So your range would be negative infinity to positive infinity. Okay? So, all right, we're going to be dealing with inverses. So sine inverse of x, all it does is it basically switches things up, domain and range flip, but there's a little bit of a tweak to the range. Your domain is going to be -1 to 1, but here's the important part, okay? Your range is from negative pi over 2 to pi over 2. Okay, this is the important thing. That way, whenever you solve for an inverse function, you know your answer has to be between -90 to positive 90 degrees. Okay, so you got to know that. Cosine. So your domain is going to be from -1 to 1. And your range is going to be from 0 to pi. So notice, the sine inverse function exists in quadrants 1 and 4. The cosine inverse function exists in quadrants 1 and 2. Okay? The tangent inverse, let me highlight this again. So the tangent inverse function, your domain is going to be negative infinity to positive infinity. But your range is going to be negative pi over 2 to pi over 2 exclusive, okay? Not including the 90-degree angles, or else this thing blows up, okay? So just a real quick reminder, this is trig information. This is not calculus, okay? This is just some trig info. So I want to make sure, and I can't recall, did I teach you guys how to take a derivative of this stuff? Of the inverses, yeah. I can't recall. So I'm going to show you guys the definitions right now. So Derivatives of inverse functions. By the way, I know homework is due today. At the end of the period, I'll have you guys turn it in. So derivatives of inverse functions. So there's 3 of them, and only 3 of them that you need to know, okay? At least for AP tests. And in actuality, it's really just 2, okay? The first one, super important, very common. d dx of sine inverse of u is equal to u prime over the square root of 1 minus u squared. This is the definition, so you just basically make it fit, okay? There's no in between that you have to work your way through to get that. This is what it's defined at. Now, this is one that's super important. The most important one that I tend to see is this next one. The tangent inverse. Okay? So the tangent inverse one is going to be u prime over 1 plus u squared. Like the derivative and the integral of the tangent inverse comes out a lot. Well, I don't want to say a lot, but if there is going to be one that pops up, it's usually the tangent inverse definition. Okay? And then the last one, which is very rare to see, but it's less rare than the other 3. That's why I'm not even going to give you the other 3. It's the secant definition. And that's going to be u prime, and that's over absolute value of u square root of u squared minus 1. Okay, so those are the 3 most common, but honestly, the second one is probably the most common. The first one is also very popular, but not as popular as 2. Third one, I don't really see it very often at all, but it does happen every once in a while. So we're just going to do some examples, and then we're going to move on to section 5.7, which is the integral portion of this. Okay, so here we go. Example number 1. Actually, hold on. Let me keep this in black here. And that's going to be differentiate. So part A, d dx of sine inverse of 2x. Now remember, definition of the sine inverse derivative is u prime over the square root of 1 minus u squared. So u prime, that means the derivative of 2x is 2 over the square root of 1 minus u squared. So 2x squared is 4x squared. And you're done. Okay? So that's it. That's all there is to that derivative there. Just know the formula. And also be able to recognize the thing in red. If you're integrating it, you should be able to see that thing in red and say, oh, that's sine inverse. Right? And we'll talk about the definition for that in a bit. But you should be able to see that and say, oh, that looks like sine inverse, the square root of 1 minus 4x squared. If it was 4x squared minus 1, I'd think secant inverse, because that's the way secant one is, right? U squared minus 1. But they use u's and a's in the main definitions. All right, let's look at the second one here, part B. Let's do the derivative of tangent inverse of 3x. Well, according to definition, it's u prime over 1 plus u squared. So it's u prime over 1 plus u squared. So the top will be a 3, then 1 plus u squared would be 9x squared. Again, this should be something that when you see it, if they're having you integrate, you should say, wait, 1 plus something squared, that's a tangent inverse definition. So when you integrate, you should get tangent inverse. But again, I'll show you a definition for that. All right, so let's do part C here. d dx of secant inverse of e to the 2x. So remember, definition for secant inverse was u prime over absolute value of u times the square root of, what is it, u squared minus 1. Okay? So u prime would be, all right, 2e to the 2x over the absolute value of e to the 2x times the square root of u squared minus 1. So it's e to the 4x minus 1. Notice I can cancel out e to the 2x on top and on bottom because e to the 2x is always positive, is it not? Normally, it's just a graph that starts flat and then goes up, never crosses the x-axis. So these actually cancel. So it's just 2 over square root e to the 4x minus 1. All right, and last one, I'm going to have you guys try this one on your own here. Part D, d dx of sine inverse of the square root of x. So try that, I'll give you a couple minutes. So definition for sine inverse is u prime over the square root of 1 minus u squared. So u prime is 1/2 x to the negative half. And then the derivative of x is just 1, so we don't need to do that. Over the square root of 1 minus square root of x squared, which would be x. So we'll just clean it up a bit. 1 over 2 radical x times radical 1 minus x. And if you want to go a step further, you can combine your radicals. 1 over 2 square root of x minus x squared. All right. So at this point, you guys are ready to work on homework for this section. I'll write down the assignment at the end, okay? Because I'm not going to go over a whole bunch of the other stuff. But this was just differentiation of these functions. Remember, at the very beginning, I just defined them for you, what the inverses are. Remember, all your answers for sine inverse of whatever, sine inverse of 0.5, cosine inverse or whatever, they have to be within that range for sine, cosine, and tangent, okay? Make sure that they land within that range. If they don't, then you're going to get the answer wrong, okay? So your angles for sine should be within negative 90 degrees to positive 90 degrees. For cosine should be between 0 to 180. Tangent between negative 90 and 90, but not including the negative 90, not including 90. Okay? And then we just went over derivatives. So let's talk about the integrals. Okay? So integration of trig inverse functions. And there's only 3 that they really want you to know. The tangent one, very important. The sine one, also important. Secant one, very rare, but you know, it's one of those that they're kind of interested in you knowing. So here you go. Very first one. We'll do the sine one first just to kind of keep it consistent with the other stuff. So the integral of 1 over the square root of a squared minus u squared du. Okay, so if it looks like that, then it's sine inverse of u over a plus c. Now it's your job to make it look like the first part, okay? Make it look like the integral of 1 over, and I mean, maybe it's not a 1. If it's a 2, you just put the 2 in the front. But 1 over a squared minus u squared du, okay? Second one, the integral of 1 over a squared plus u squared du. And this is probably the most common one. This will be 1 over a tangent inverse of u over a plus c. And the last one, the integral of 1 over the absolute value of u square root of u squared minus a squared du. Alright, let's see. Well, I guess we don't have to put the absolutes. I thought we did. So you don't need the absolutes on it. I thought you did. So it's just 1 over u times the radical u squared minus a squared. So this is 1 over a secant inverse of absolute value of u over a plus c. Okay, so we're going to do some examples, and then I'll give you guys the homework for these two sections. So example number 2. Integrate the following. So here's the first one. We're going to do the integral. They write dx on top. I don't like that they do that in books, but whatever. You can move it to the side if you want to. That's my preference, but whatever. Square root of 4 minus x squared. So which one of those three functions am I going to use based on the way this looks? The sine inverse, right? Because sine inverse has a subtraction. It has the constant first inside the radical and then the function second. Okay, and that's what I have here, 4 minus x squared. So first thing I got to do is define the pieces. So my u is x. My a is 2. I'll show you that right now just so you can see. So 2 squared minus x squared. Okay, so my u is x, my a is 2. Now that I know what u is and what a is, then I just got to use my definition. Sine inverse of u over a, x over 2, plus c, and I'm done. That's my answer. So identify your u and a values, and then you're just going to be able to plug them in to your definition. Part B, integral of dx over 2 plus 9x squared. Oh, and by the way, you know what I forgot to do? I forgot to take a derivative of my u function. du is dx. So obviously nothing else changes. There's no like leftover numbers. So nothing bad happened that I forgot that, but something bad will happen if I forget to do that here. So I just want to make sure you should be taking your derivative of your u substitution, right? So here, I am going to let a equal to, well, it's supposed to be something squared equals 2, right? So it would be the square root of 2. That's my a value. My u value is what? 3x, so that means du is 3 dx, so a third du is dx. So let me go ahead and start substituting back in 1/3 integral. Okay, and then right here, I'm going to start rewriting. My du should just be up here. The 2 is going to become my, I guess you could say my radical 2 squared, right? Plus 3x squared. Actually, I put a du up there, huh? I should probably make those into u's and a's, if you guys don't mind erasing. Sorry. Let me just put a here, u here. I just remembered I put my du up there. So according to definition, this will be 1/3, right? And the integral of the thing on the right side is 1 over a tangent inverse of u over a plus c. But let's plug in our a and u values. So that's 1 over 3 radical 2 tangent inverse of radical 2, I'm sorry, of 3x over radical 2. You'll notice we didn't have to do any of that rewriting for sine because that one was pretty easy. There was no like numbers left over that I had to substitute in and put into it in front of the integral. Nothing like that. For part B I did. So I had to kind of rework it, rewrite it, and eventually find my answer. Okay, last one, then we're done. Obviously this has to be a secant problem because that's one we have not done yet. So integral dx of x square root of 4x squared minus 9. So the thing about the secant one is that your u function has to match the inside and the outside. Now look at the inside of my square root. What's my u function? 2x. Now, is that the same thing on the outside? No, it's missing a 2, so I can introduce one. 2 dx over 2x square root of 4x squared minus 9. So I just multiply by 2 over 2. Okay? Now, at this point, I know that my u value is going to be 2x. So my du is 2 dx. Now notice, I do have a 2 dx up on top, so I'm just going to leave it like that, okay? So du will take over the 2 dx. And then my a value is 3. Okay? So let me plug that stuff in right now. So this will be du on top over u square root of u squared minus a squared, right? That's what it looks like right now. If I plug everything back, it looks just like that. So that's going to be 1 over a secant inverse of absolute value of u over a plus c. and then just plug in your information. So your A term is a 3, secant inverse of your absolute of 2x over 3 plus c. Right? So I'm going to write down the homework for you guys right now, but that's basically sections 5, 6, and 5, 7 kind of quickly.